Zero Trust is a modern cybersecurity framework that operates on the principles of never trust, always verify. It assumes that threats can exist both within and outside the network of an organization. As businesses adopt more and more cloud services and remote work models, requiring more robust and adaptive security measure has become important. Hello, everyone. My name is Abhishek Tiwari, and I will be going through some of the important elements of zero trust in this session with close to 19 years of experience in the IT industry and the past 6 years in the identity access management. I consider myself fortunate to get first-hand experience implementing zero trust. Now, it is important for us to understand what the zero trust means before we go into the nitty-gritties of zero trust. As per the definition by some of the leading institutions like NIST, zero trust is a cybersecurity model that is based on the principle that no one, whether inside or outside an organization, should be automatically trusted. Instead, trust should be continuously verified, and strict access control mechanisms should be enforced whenever a user is trying to access any kind of resource. The model assumes that a threat can exist both within and outside an organization. The core principles of zero trust are: number one, never trust, always verify. Zero trust assumes that a user, device, or an application should always be treated untrusted, and always the access to a resource should be verified before the resource can be accessed. It has the least privilege as an important principle, wherein the access should only be given as is required, nothing more, nothing less. From a network perspective, microsegmentation is an important principle of zero trust, wherein segmentation is done to make sure that in case of any breach, the impact is minimized and the attacker gains limited access to the network. Continuous monitoring and evaluation is another important principle, wherein access is not only determined at login but also reevaluated throughout the session to detect any suspicious activity. Multi-factor authentication has gained significant prominence as part of zero trust. And finally, data protection is the last but not the least important tenet of zero trust. And it is important to protect data of organization both in rest, in transit, and in motion. With that, let's move into the important components of the zero trust architecture. The first and foremost being the control plane, which has the policy engine, the policy administrator, and the policy enforcement point as the key blocks. Policy engine is like the brain of zero trust, wherein there is decision making done before the access is given of a resource. The decision making is done based on numerous inputs and data sources that we will go into in a while. Once the decision is made, the signals are passed on using the policy administrator to the policy enforcement point, which is eventually the module which enables the monitoring and giving access of the resources to the system. Now, there are different kinds of data sources which help the policy engine in making decision whether access should be granted or not. The key ones being the continuous diagnostics and mitigation, which is more like an element which checks the posture of a device, whether a device has all the right kind of hardening done, whether there are latest operating systems, patches being done on the device. Only then the device is considered as a trusted device. Industry compliance is another important tenet through which different compliance like SOX or HIPAA is enforced in the zero trust principles. Threat intelligence helps in the decision making by identifying any newly discovered attacks or vulnerabilities like zero day attacks. Activity logs play another important role by continuously checking what type of access is being requested by a user or by a device on a very, very live basis. Um, Data access policies is another important aspect which helps in the decision making. This is basically revolving around what type of data is being requested by the user, whether it is a very confidential or a sensitive type of data. And based on the tagging of the data, more controls are applied or sufficient controls are applied. Public key infrastructure is very important for generating and logging certificates, which sometimes are used by organizations to do trust-based authentication. Identity management is another fundamental block in the zero trust architecture, wherein the different identities which are stored are accessed through protocols like LDAP, and the information of the requesting party is also fetched using the ID management of an organization. And last but not the least, security information and event management helps in collecting live feeds of the user, whether the user is logging in from a risky location, whether there is an impossible travel scenario. All that kind of features are gauged by the SIEM system. With that, let's move on to the important components of Zero Trust. The first and foremost being identity and access management. Now, identity is at the core of Zero Trust, and Zero Trust heavily relies on a robust identity management system. The key elements of identity and access management from a Zero Trust standpoint is number one, where is the identity stored? Is that secure enough? Number two is the life cycle of the identity, which is making sure that across the life cycle of joiner, mover, and leaver, sufficient controls are implemented so that when a user joins an organization on a timely basis, the required access is provided to the user. And similarly, when the user has been terminated from the organization, the access gets revoked on a timely basis. Access management heavily relies on elements like multi-factor authentication and policy decision point through which different controls and policies are read and only then access is granted to the user. Now in this diagram over here, we again see that a user is trying to access an application, and before the application access is given, the policy enforcement point goes and checks from the policy decision point as to what type of user this is. Is this a user which has been tagged as a risky user? Is the request coming from a geography which is tagged as a risky geography? And has something changed in the posture of the user compared to the previous login? So all those things are checked and only then the access is given to the user. The next important element in zero trust, or the next important component, is network, wherein there is again no implicit trust. There is a lot of context aware security which gets applied whenever a user is trying to use a network to gain access to an application. So by context aware security, it is primarily revolving around tenets like what is the user's identity, which is the device from which the user has logged in, what time of the day the user has logged in, is there anything abnormal in that. Microsegmentation helps in breaking down the network into logical blocks so that in case a bad actor gets an access to the network of an organization, the damage is limited only to that particular segment and not the entire organization. Firewalls have evolved in due course over the time, and a lot of the context aware security principles get applied using the next generation firewalls which are available currently. Security Operations Center play a very crucial role in the dynamic security check of any kind of request. Now here, let's look at the flow depicted in the diagram, wherein a user John Doe post authentication is trying to get access to an application. Now, before the user is given the access, there is a policy decision point which makes an API call to the SIEM system or the SOAR system of the organization, which has live feeds coming in from the servers or the network devices or the intrusion detection systems. And these feeds help in determining whether the user has significant threat or moderate threat, or this is no threat scenario. It also helps in determining whether there is a high risk associated with the user. Based on these determinations from the SIEM or the source system, policies are applied. Now, again, in this example, there are two policies listed. If the user has a threat level of high, then the organization will grant the access, but this time the user will have to do multi-factor authentication, and only then the access will be given. The second policy that is depicted as an example here is the risk level of the user. Unless and until the risk level of the user is low, privileged access is not going to be granted to the user. So all these live checks are done using the Security Operations Center. Privileged access management is another important element of Zero Trust, wherein privileged access has to be always authenticated carefully. There should be mechanisms like step-up authentications, which should be applied whenever any kind of privileged access is being requested. Elements like just-in-time play another important role in reducing the risk and implementing Zero Trust principles. Finally, data protection, as we all realize, data is similar to what oil is for the energy sector. Data has to be protected at all the instances the data is created, whether the data is in rest, the data is in motion, or the data is in transit. Relevant data protection mechanisms like encryption should be applied to protect the data. There should also be mechanisms in place to recover data in case of any kind of data loss. And similar to identity access and identity governance, data access should also be governed by applying security controls like multi-factor authentication or role-based access control. And there should always be a detection and analytics by applying and monitoring any kind of risk that the user has to make sure that the access is only granted after checking for the risk level of the user. With that, I come to a closure of the Zero Trust overview. And there are four important takeaways that I would like to share with all of you. Number one is, like any large program, Zero Trust will only be successful if there is a leadership buy-in. Unless the leadership supports the program like Zero Trust, it will never be successful. Application access is extremely crucial. Organizations should implement some of the good identity governance and administration tools to make sure that application access is only given when required and to the right people at the right time. Multi-factor authentication, as we discussed previously, also has very important relevance. And finally, network security to make sure that the network access is protected. With that, I'll come to the closure. Thank you.